Let's start our tutorials by talking a little bit about FFmpeg. FFmpeg is kind of this like Swiss Army knife tool that is going to kind of run behind the scenes of everything we do in this class. And some of you might not care at all about the code that underlines this stuff. You may just be happy that all the tools are made available to you and you just run them. Others of you I know are kind of interested in like how the sausage is made and that sort of thing. So FFmpeg is a very important tool for pretty much any video production. I think like probably behind the scenes, like everything is running on FFmpeg, especially if it's a tech platform. It just is the thing that people use. So let's go ahead and get started with this notebook. We don't need a GPU for this. There is a version of FFmpeg that runs on a GPU. It is impossible to install and it takes forever, and it's honestly not worth it for collab. Maybe in the future I'll try and get it running for this class, but it's really a huge pain in the ass. So we should just get an error message here because we don't want to run on the GPU. If you do get a GPU, sorry, I should mention this in more of my videos. If you do get a GPU that shows up here, the way to fix that is to go to Runtime, change runtime type, and select CPU, and then hit save, and then you'll need to restart. Let's connect the drive because we want to play with some videos. And then we usually don't need this, but I always include this in FFmpeg notebooks just in case. So usually the versions running on Colab are not the most up-to-date. Let's check and see. So if I run this command, this will tell me what version of FFmpeg is installed. The version in here is 4.42. I don't know what the latest actually is. If you want to upgrade to the latest and greatest, you can run this cell. And hopefully this doesn't take 10 minutes. In fact, looks like it might not even run anymore. Let's see. Looking good so far. This does take a little bit of time. So again, not ideal. It's also like not really necessary. Almost nothing we do in this class is going to be running like the latest brand new versions of FFmpeg, because the stuff that they're fixing or adding to are like pretty like out there. But if I run this next cell now, you will see, oh, it still says we're running 4.42. So I don't even know if this did install correctly. Oh, it says already the newest version. So we're already actually upgraded, so that's great. Maybe in a couple months time, you might try and run this and it actually does upgrade. But for this class, we're probably good here. So you can just skip the past minute or two of wasted time that I just ran everything through. Sorry. Okay, so what I've done in this notebook is actually just listed some really common FFmpeg functions. These are ones that I basically write by hand every day, or will definitely write in this class. And they're also really common ones that I think you'll probably want to use in this class. So let's start with the first one. This is just splitting videos into frames. So again, we talked about this week, like, should we use a clip or should we use individual frames? And a really common thing you need to do for most video is split up into individual frames so you can then like cut and paste or bring an image into Photoshop or that sort of thing. So the way FFmpeg works, especially in Colab, is it always starts with FFmpeg. That's just saying run this application. Next will almost always be a -i, and that is, here is the input file that I'm going to use for this video. The basic structure of FFmpeg is, as a command, is give me my inputs, do some stuff with that input, and then output it to this location. So a lot of times it'll be -i, video, a bunch of gobbledygook that you don't understand, and then at the end will be another video path. That's the basic format of FFmpeg, and that's really all you need to know about using a lot of these commands, and then you just copy and paste it or like Google about stuff. So we need a video file. So let's just go in here and let's grab one of our video files. So we'll go to Algo Film, go to downloads, and we will go to, well, let's go to this file because it's pretty small. So we will paste this path in. So this is our path here. That's a long path, but that's what we need. Next is this -r. Actually, you know what? I'm going to delete this for now. We don't need it at most cases. The next thing we need to do is we actually need to output this to a location. And what we're going to do is let's make another folder in here. You'll see I already have it. It's called frames. Generally, I recommend setting this up like this structure just so you can keep an eye of like, okay, am I talking about clips? Am I talking about downloads? Am I talking about frames? So inside this folder, let's just make a new folder and let's just call it, well, this video is called NYC dumping. Your video might be called something else, so just call it test. And let's copy this path to this folder. Let's keep what is happening here. I'll talk about this in just a minute, but let's keep what's happening here and just paste our new folder in. So now I have a folder path / this %09d and .png. Okay, so what this is saying is take this input video and output it to this format. So output it to this folder and then make a bunch of PNG files. Now what this thing says is it says for every image we output, increment or give that a 9-digit number. So it will be a 9-digit number that starts at 1. So it'll be 0000001, whatever that is, 9 digits, at a 2, 0000003, until it's finished. So let's actually just go ahead and run this. Okay, Bug, we get it. And we'll see what happens. So as this runs, and I open up this folder, you'll see it just processes out a bunch of PNGs, and they're all sequenced in this way. Now, I like 09D because it's just a nice long number. It means if I have an hour-long film, I probably won't use up all these digits. If you're like, I can't see that many zeros, you can make this a smaller number by changing this value. So 03D would be 3 digits, which means it would be 001. Now, the problem with 001 is if you have a long enough film, eventually it's going to run out of frame counts. So you just have to be a little bit careful with what number you actually use. I like 09D. It's a safe number, and it's honestly one that I use quite often. So this is going to output a frame for every single frame inside this video, meaning whatever its natural resolution is, or sorry, natural frame rate is, it's going to output a frame for that. So if the frame rate is 30 frames per second, and it's a 1 minute long film, you're going to get, what's the math there, 1,800 frames? Did I do that right? I don't even know if I did that right. Anyway, it's going to be a number that is 30 times 60 because there are 30 frames per second and it's 60 seconds long. That is by default what will happen. If you don't include anything else here, that will be by default, you will get that many frames. So this looks like this is still running. I don't actually know how many frames are in this piece. Still running. Okay. Well, while we wait for it to finish, let's talk about how we can get less frames out of this. So a common thing we want to do is, let's say we want to process, I don't know, a couple frames a second, because we don't really need all 30 frames because it's going to be very little moderate change between them. Let's say we actually want 2 frames per second. How would we have this generate automatically 2 frames per second? We could, in Python, go through this folder and just like count every other, like, you know, every 15 and only grab the 15th frame. That's going to fill up a lot of our hard drive during a bunch of PNGs like this. I should also mention you can set this to JPEG. You can set it to TIFF. It'll generally figure out what the format needs to be based on what you put output there. I like PNGs because they're not super compressed like JPEGs, but they're also not really large like TIFFs. So PNG is kind of what I go to. Sorry, back to the frame rate question. Let's say I actually want to output, instead of 30 frames per second, let's say I only want to output 2 frames per second. The way to do that is to do -R and then put in 2. What this will then say is instead of doing the natural frame rate of whatever the video file is, let's actually output 30 frames per second. So instead, let's do something like 2 frames per second, right? So this will actually only generate 2 frames from the video every second that the frame is, or the video is running for. This is much more helpful when you are doing stuff like trying to process, like maybe you're actually trying to look at motion. You know, if whatever tools you're using can't actually look at video natively, this would be a good way to process each frame individually and then do some computation across all those frames to figure out what's going on. I don't know why this is still taking this long. I don't think it's that long of a video. Let's just hit stop here. Yep, okay, so cool, so that stopped. So if I refresh this, you'll see I've got all of these files here. If you ever want to delete a folder, you'll notice if you try to delete this way, it'll just say you can't do that because these files are not empty. The easiest way to do this is to just go into a cell in Colab and do rm-r with the exclamation point at the beginning, and then paste in the path. And that will then, when we refresh, it'll delete everything. Gone. Now, the problem is I want that folder back because I want to save stuff to this file. If you run this, let's actually try and run this. I think it'll give you an error. Yeah, it'll say, cannot do this. And the reason you can't do this is because the path you've asked it to create, this folder does not exist. So this is a very common thing that happens, is you're going to assume it will just generate the folder for you. It does not. So let's go in here and remake our test folder. And we'll go ahead and run this again. Oh, I think the reason this takes a while is it's 1440 by 1080 for dimensions. It's pretty large. But if I go in here and save this out, you'll see, again, it's generating each frame. Now I know for a fact that this is actually generating at 2 frames per second because I know how this command works. If you want to go in and double check yourself, you're more than welcome to. I'm going to leave this as is and just hit stop because we've got to move on because there's a bunch of other things to show. Again, I'm actually just going to leave these as is. The other thing you can do, I think you can select multiple files in here. Let's see. No, you cannot. So you would have to delete each one of these one by one. That's really annoying. That's why that command, that rm-r, is really, really helpful. Okay. Well, actually, this is great because we already have these files. So let's do this. What about the reverse? A thing that we will also often do in this class is we'll generate individual frames, and then we'll have a bunch of frames, and we'll be like, well, let's turn that into a video. How do I do that? So this is actually the inverse of this, which is to create a video from a bunch of frames. It looks fairly similar, although there's some differences here. So first things first, this is like just kind of a catch-all. This isn't really in the documentation, but I find this generally is safer to do. Stick the frame rate counter in front of the input, and it will always use that right frame rate. I don't know why that is. FFmpeg is weird. Okay, so now we're actually taking the input, and the input this time is going to be what used to be our output. So we're going to read in a series, a folder of PNGs, and those PNGs have the format of a 9-digit number. Now, sometimes what will happen is whatever tool we use will output something like frame-0000001. In that case, all you need to do is actually add the frame dash. And this tool is really smart and will still understand, like, okay, well, now I'm looking for a file in the pattern of frame dash numbers. So this is kind of cool. It's really easy to use. The thing is, you have to remember that your numeric count here matters compared to this. And different tools will output different numbers. It gets kind of messy. Anyway, that's why I always stick with 09D, because it's always what I do, and then I can always figure out what the inputs are. Once again, we add the frame rate in here. Again, it's just like a thing I've learned that works. So do the frame rate twice. It looks weird, but it works. Next is our V codec. So this is what codec we're going to use. It has taken me like a year to memorize this data. This is my default go-to. This is the codec and the pixel format that will basically always open in QuickTime. So if you're ever looking for like a default thing that you can upload to Instagram or Twitter or...
One moment.
Boy, that was weird. If you're ever looking for the format to just default use for Instagram or Twitter or any other social media account or just QuickTime in general, or if you're opening a file and it doesn't open in After Effects, this is the codec to use. This is a general 264 codec with the right color format to open in QuickTime. It is not the highest quality. It is definitely compressed to a certain level, but it's generally very good, like a general default good testing video format. Last, we need to output our video somewhere. So in this case, what I always generally do for tests is I just dump them into my content folder. This folder here is called the content folder. So if you just set this to content, and then you set this to video.mp4, we can now run this and it should work for us. If I refresh over here, you'll see I've got video.mp4 and it is now finished. Now, this is going to be a very janky looking video because we output 2 frames per second and then we read it in at 24 frames per second, so it's going to be very sped up. Don't watch it, doesn't matter. If you want to go back and actually fix this, you can. But for the most part, like, this is all you need to worry about. So this is how you convert a series of frames into a video. Next, let's talk about resizing. Oh, and I should also mention, if for whatever reason you have a bunch of image files that you don't, like, are not sequenced in the right way, you can use this command to actually produce what's called glob, which means it's like some sort of matching pattern. So let's say you just have a bunch of random .png files in a folder. you could set this folder path and leave the asterisk here as a wildcard, and it would just sort of put everything together. Not ideal, because if your stuff isn't the same dimension, it's going to probably throw an error, and it's going to look very fast and very noisy. Like, set this to be like 6, so your frame rate isn't all over the place. But this will work. It's definitely not as safe as using the pattern matching, but it does work if you want it. Okay, now let's talk about resizing video. Again, very simple format. The format here is your input video and your output video. So let's grab a different video here. Let me just go to Algo Film. We'll go to the Groundhog Day film, so we'll copy this path. We'll paste this in. Now we can also look at FFProbe to see like what dimension was this thing. So let's add a cell here and go FFProbe. Oh, we actually haven't talked about FFProbe yet. I'm doing my videos out of order. But anyway, if you're interested in seeing what the dimensions are, we'll cover this in the next tutorial. But you can run this, and this will spit out a bunch of data for you, and we will see here that this video is 1920 by 1080. So at this point, we can go ahead and close this. We'll delete this cell. So we want to scale this down, right? So there are 2 ways to scale down. Well, I guess there's many ways to scale down, but the easiest way to remember this is in this scale function, it's going to take in a width and then a height. So x, y. So let's say we want to actually make this something like 640 wide. Now, the key here is like we don't actually really want to distort the image, right? We want to keep the same scale. And the way to keep the same scale is to use this -2. Now, there's actually a -1. -1 will scale your images down, but it might also produce an odd size dimension. And if you haven't heard anything else I've been complaining about FFmpeg, FFmpeg does not like odd dimensioned resolutions. So if it's like 1081 by 1921, it's going to complain. So the -2 will always make sure it's an even number. So that's kind of what's nice here. So what this is going to do is it's going to scale our video to be 640 on the width, and then whatever the aspect ratio stays the same for the negative for the height. And we'll always make sure it'll wiggle the number a little bit to always make sure it's even. So let's go ahead and copy this again. We'll do content here, and we'll do scaled video. Go ahead and run this. And that will scale your video. I'm going to stop this just because I want to move on. But if you let it complete, you will see a scaled video file over here that is scaled. Next, let's talk about cropping. So cropping a video is kind of the same, although it takes in slightly different proportions or different inputs. So again, let's grab our Groundhog Day film. Let's grab this path. Paste this in. And this time we're going to use the crop command. So again, you'll see here that there is a scale command, there is a crop command, there are millions of other commands within FFmpeg. But you'll always notice that they're sandwiched in between the output and the input. That's the key here, is think about it as like a pipeline essentially. So these 4 numbers after the crop are this. So output width, output height, X and Y. So remember that this video is 1920 by 1080. So let's say that I want to make a crop of 1000 by 600. So this is going to make a crop that is 1000 by 600. And then we've got X and Y parameters. So where should I crop this from? Should I crop it from the top left? Top left is 0, 0. So the coordinate grid for these are 0, 0, and then whatever the height and width are from the bottom. But remember that if you're cropping from this dimension, you actually need to make sure that you've got enough space there to actually crop into it. This gets kind of complicated. I would say if you're going to crop video, it might be safer to just do it in a video editor. It's just easier to remember or easier to manage and manipulate. If you want to do the math just to figure out how to do it in FFmpeg, you're more than welcome to. The other thing you can do is actually remove these last 2 numbers, and this will crop from the center. So this is probably the safest, easiest way to do it. It's just going to create a crop from the center, but sometimes it's not always what you want. So those are the dimensions. So this is size I want to crop to, and then this is the X position to start the crop, and the Y position to start the crop. So it's always the top left corner of whatever you're cropping to. I'm actually just not going to run these because it takes too long. So that is this command. So that's the crop command. And as I mentioned, if you delete those last two numbers, it'll crop from the center, which is kind of nice. Someone asked me, I think it was Aman asked me about trimming the video length. So here's another one that is kind of a little convoluted, but I'll explain how it works. So let's say you want to trim the video length. So let's say you've got a 20-minute long film and you only want to work with a 30-second clip of it. Now, I'll be honest, easiest way to clip to like the right place is to open your file in QuickTime, hit Command-T, and use the trim sliders. It generally works way better than trying to figure out this exact dimension. But if you want to do this from here, you're more than welcome to. So the way this works is using -SS. This is the seek command. So this will seek to the point in which you want to start your trim. So this, let's say we want to go 30 seconds into our video. And then here is our video that we want to actually use. Again, I understand that it's confusing that sometimes you stick these things in front of the input and sometimes you stick them after. In this case, it's easiest to stick it in front of it. It's complicated if I were to put it in the middle. I don't even want to explain that. Let's just say this. So where you start from goes before the input. So I'm going to say I want to start at 30 seconds in for this video. So you pass your input path. And then it says 2. And this is the length of time from when this started. So this is, I want to go 10 seconds after this start time. So this will generate a 10-second video from 30 seconds to 40 seconds. And then you can use -C copy to just use the exact same codecs you were using before. That's the easiest way to work. And then you give it an output. So this will trim your video to a certain length of time. Again, I think in this case, a GUI is way cleaner. And the QuickTime GUI is actually not terrible for trimming. You know, again, it might change your file quality a little bit, but so does this. I should mention anytime you alter stuff like this, you are actually going to degrade the video just slightly. Again, if you're doing libx or lib264, then it won't be terrible, but it will be like a little bit. If you do this over and over and over again, you will degrade the video down. Lastly, I think Esteban asked me about this one, which was he somehow downloaded a video file that was like from YouTube, and the video format was unopenable in QuickTime. This is a very common thing. It happens quite often because I think YouTube DL especially wants to download like WebP and other shit. In this case, what you're going to do is just feed it the input path, which might be something like a WebP file or an MKV file, or maybe it's ProRes and it's an MOV file. Just give it whatever input, it figures it out. And then you stick these little, impossible to remember, but I have finally memorized them, vcodec and pix format. Stick that in between and then give your output. Your output always needs to end in MP4 for this format. And that will convert your video. Again, it will slightly degrade the quality because it's changing codecs and stuff and compressing things. But in general, it's going to be a lot cleaner. So that is all the common FFmpeg commands I want to cover today. People might ask me for more in the future, and I might add to this notebook as like people ask me for more things. But in general, I think these are the most common ones that people ask me about. Lastly, I will say I taught a class last summer, maybe 2 summers ago now. Jeez, was that really? Yeah, maybe 2 summers ago now. That is all about FFmpeg. So if you want to dive deep into this, there are 4 weeks of like 2.5 hour lessons on YouTube at this link. We go into some crazy stuff you can do with these input formats. You can crop stuff in little pieces, reassemble it, change colors, do all sorts of weird stuff with it. And in Colab, you can even run Python to actually generate your command, which gets really crazy. So if you're really interested in doing some really fun and weird stuff, check out this video. We will probably not cover a lot of that in this class, so it's kind of like these are 2 companion pieces to each other. If you want it, it's bonus video, bonus material for you. Okay, so that's it for FFmpeg. Now we're going to look at FFprobe, which I've already sort of hinted at, but that's what we're going to do next in order to grab dimensions, frame rates, and duration from our video clips. Oh, and one last thing, because I keep forgetting to tell people about this. When you're done with your notebook, make sure you shut it down. So come here, click on the little arrow, and hit disconnect and delete runtime, and say yes, and now your machine is shut off. You're no longer being charged for it. Now we can go off to FFFFFFF. Now we can go to FF probe, and I'm soon to lose my mind, so I might call it a night. All right, bye.